Welcome to online classes. I am Shilpa, lecturer in DCME, working at Dr. B.R. Ambedkar GMS Polytechnic, Karimnagar. We are discussing OOPS through C++ subject. In that, we are discussing inheritance concept. So, in previous lecture, we discussed what is the need of inheritance, what is meant by reusability, how we can create a new class from existing class, what is the syntax for inheritance, that is creating a new class from existing class. What are the different types of visibility modes or access controls? In that we have discussed what is public derivation, that is in inheritance the definition of the inheritance is creating a new class from existing class. So as we are saying, class may consist of private, public members. Each and every class may consist of private and public members. Even here they may have protected members also, but till now we used only these two access specifiers, that is public and private, and we did not use this protected keyword. This is not nothing but this is in the access specifier. So, and we also know if we specified a members either public or private, then what happens to the accessibility of the members which declared under this public and private sections. Okay, now here we are discussing the types of derivations. Types of derivations, namely they are public derivation, private derivation and protected derivation. So before going to that, normally here when the members of a class declared under this public section, these members can access in its derived classes as well as in any part of the program directly. That is, in even main we can access these public members of a particular class directly. That means, of course, using or through the object of the class. Always, in order to access the members of a class, we need to create an object. Okay. Using that object, we can access the public members directly. If a class consists of private members, then these private members can be accessed within the class but cannot be accessed in any part of the program or out of the class. Private members cannot be accessed out of the class, and of course the accessing of these private members can be possible using the public members of the class. Using the public members of the class. Here public members means obviously the public member functions. Using public member functions, we can access the private members of a class. Okay. And what about protected? So if you consider this public and private, public means they can be accessed out of the class using the object of that class. That means we are not at all providing any security over the data of the class. By creating only the object for that class, we can able to access all the members of the class because all these members are declared in public section. Okay, no security over the data. If the members are in private, then we cannot access these private members out of the class. That means pure security or purely we are providing security over the data of a class. If we are strictly preserving or providing security to a particular section or to entire class of the class or members of the class, then we cannot access these members out of that particular class. Then what is the use of creating that particular class? Without providing accessing of any part of the class, that nothing is used by creating this particular class. So that is here there may be drawbacks and advantages of the public as well as the private. Private provides security, fine, but cannot be accessed. If you are not able to access, then there is no need of creating all these things. And public, so everyone can share the can view or can make use of the public members of the class. Then that means here anyone can modify the data. That means not able to provide security over the data. So these are the drawbacks of this public access specifiers and private access specifier. So in order to overcome these problems of these two specifiers, here we are having one more access specifier, that is protected. So protected members are those which can be accessed in its immediate derived class. In its immediate derived class, but not in any other part of the program. Protected members can be accessed in its immediate derived class. Okay, so here we are providing accessibility to the members of the base class as well as we are providing security over the data. So that is the main use of this protected access specifier. So in previous class we have observed how this public derivation can be takes place. So here when we are derived publicly, public derivation we use in order to create the derived class, that is student from the base class person. So here it can able to access uh, all the data of base class. That is here it call this age, because here this age and get age are public. Even this particular derived class can call this get age and age in its body. So here we call here in void display, that is the member function of this derived class. We call the variable age, which is of member of base class, that is person directly. Okay, and in main you can directly call the member function of the base class, that is get age, using the object of the derived class. Because when we are deriving a class, a copy of the base class will come into the derived class. A copy of the members of this particular base class come to the derived class. So directly by creating the object for the derived class only, we can directly call the member function of the base class, in this case getAge. Now we will discuss private derivation. So here when we are privately deriving members, privately deriving a class. Okay, the private derivation means that the derived class can access the public and protected members of base class. When we are deriving a class, if the derivation is private, then the public and protected members of the base class can be accessed. Base class can be accessed. Okay, so when we are deriving a class, this is a derived class. When we are deriving this class in private derivation, then the public members and protected members of the base class can be accessed. But in which mode we will discuss. Of course, the private members cannot be accessed. So the public and protected members of the base class can be accessed in derived class, and the public and protected members of the base class becomes private members of derived class. So normally here these are public and protected to the base class, but when we are deriving a class from base class in this private derivation, then all the public and protected becomes private. Public and protected of base class become private. Okay, they will become private in derived class because the derivation is private. That is, we are providing security. Private. We don't want to share the data to anyone. So we want to make the data of base class as private because the derivation is private. So though the members here public and protected, they become private. Okay, so this is the public protected members of the base class becomes private members of derived class. That is, the inheritance becomes private in the derived class and they cannot be inherited further. So when these public and protected members of the base class became private to the derived class, private members here, if you observe this second line, private members cannot be accessed. X, that is into mark. No. Okay, wrong. They cannot be accessed. So here, when the public and protected members of the base class became private in private derivation in derived class, they cannot be accessed further. They cannot be or inherited further. So here, the private members of a class have strict access control. Always the private members have strict access control. Only the member functions of the same class can access these members. What is that strict access control? Only the member functions of this particular class to which these private members belongs. Those member functions can only access the private members. And the private members of a class are inaccessible outside the class, obviously. We cannot access the private members out of the class. They are inaccessible outside the class. And thus providing a mechanism for preventing accidental modification of the data members. So, as the private data cannot be accessed or inaccessible outside the class, that means here we are preventing accidental modifications of the data members of base class as well as the derived class. Okay, and information hidden is implemented. So here, though the data public and protected in base class, in derived class that is becoming as private. That means we are simply hiding the information. Hiding the information. That means here the information hiding is implemented using this inheritance concept and when we are deriving in private derivation. Okay, and the private members can still access. Of course, there is one way to access the private members always. Normally, the private members cannot be accessed. Okay, but there is one way in order to access the private members. And access control in C++ has objective of reducing the likelihood of bugs and enhancing consistency. Always here the access controls in C++ aims for what? Reducing the bugs and enhancing consistency. Okay, we are providing based on our requirement. Either we are specifying some part of the class as public, private and protected and we want to reduce the likelihood of bugs that is happening of the bugs and we are providing or enhancing, improving the consistency of the code. And the class should have at least one member that is not private. So whenever there is private derivation, all the members of this base class becoming as private. If that is private, that cannot be accessed out of the class. That means we cannot make use of either base class or derived class further. That may be in main or any part or inherited class or any part of the program. Again, there is no need of writing a code like that. So always there should be one non-private member function. At least one member that is not private, through which we can able to access the private section or private members of both base and derived classes. When we are using this private derivation, we need to make sure that in the derived class at least one non-private member function is defined in the derived class, so that using this non-private member function we can able to access the members of derived class as well as the base class. Here, for example, how we can make the members as private using only the keyword private. Okay, private and int age, int get age. Okay, and this is the private derivation. So as usual, here we are deriving a class student. So this is the class, we need to use the syntax, that is the keyword class, and followed by the name of the derived class. In this case, that is student, and colon, and we are deriving this class from person. This is the name of the base class. In which mode or in which derivation? Protected derivation. So we are discussing private. So private derivation. Okay. In private derivation, we are creating the class student from base class person. Okay. So all the data of this base class become private in student class. So in order to access them, here we require at least one non-private member function. Okay. So this is the one. Now let me open Turbo C++ and we'll see one example program how a class can be created in private derivation. In private derivation, and this is the previous program, which is public derivation. We use public members in the base class as well as we use public derivation in order to derive student class. Okay, so simply class person in public int age and one member function get age. So it assigns value for the member age, and we are deriving a class student in public derivation from this person, and it is having its own data member and member functions. One data member is pin number, and this member function is used to assign value for that pin number, and one member function that is display in order to display that member function. That's it. So here we are not at all calling any members, or we are not at all using any members of the base class in derived class. Normally you can create, you can use. Okay, for example, here if I want to use the member age in derived class, simply here I can use age is simply use the variable age. Simply use the variable age, because here this is age is a part of the derived class student. When this student is derived from the person, directly it will get all the copies of the base class, that is age, and get age into the derived class student. So here normal like pin number, here age also accessible, and we can make use of that in derived class. Okay, so here simply main, always we need to create an object for the derived class, that is the student, and using that we are calling get age, that is this is actually the public member function of the base class. Of course when we derived student class, so this get age will come into the student class. So directly using the object of this derived class we can call get age, and of course this get pin is on the public member of the derived class only. So directly using this object or through this object we can call that. And here in order to show you even the public members can access in main. So here see out the age is s dot age, and always the public members of a class can be accessed in main using through only the object. So in order to show you here I use this s dot age, and after that I call another member function of the derived class. So this is previous program actually, but once run it and see the output. Enter age 18, finish 501. So we are getting that. Here why we are getting the age is 18 and age is 18, because in display also I used age, I displayed the age, as well as in main also I printed see out the ages. Okay, that's why we are getting 2 times age. Nothing is happened, because in order to show you only I use, that is even in derived class the public member of the base class can be called directly, and if we want to call the public member of the base class in main through object of the derived class, it is possible. In order to show you here I use these two cout statements. Now actually here till now we discussed private derivation. Okay, so for that here I want to make these members as private, all the members of base class as private. Okay, that is the member age as well as the member function get age. Okay, and even I use this private derivation. Okay, and forget about everything that is the code which is after and all these things. First let me compile it, so that what we will get, we will see 3 errors. See, person age is not accessible in that is line number 24, and then 32 get age is not accessible, and age is not accessible in 34. So let me show you 24, 32. This is 24. Age is age. Okay, because here the age is private. Age is private. The private member cannot be accessed out of the class. Okay, so when though this student is derived class from the base class, we cannot access that. Okay, because that is private. And in 34 and 36, right? Here also the age is s dot age. It is not allowing even the derived class to access the private member of the base class. Then how it allow the private member of the base class in main? So obviously we will get an error. And in 36, of course, that means when it is want to display, that is here in display also we got this particular error. Okay, so this is the drawback, that is this is not the way to access the private members in private derivation of a class. Okay, so in order to access all these age and get age and everything, here always we require at least one non-private member. In order to make use of any class, we require at least one non-private member. So here what I am doing, I am making this get age as private, public. Okay, and also here I want to create one more public member void put. put age. Simply what it do, it displays that age. Cout age is, okay, age is age. Okay, so private members functions directly can access the private data of the same class. So this is the one I included, and after that the derivation is private only. Here pin number and get pin, nothing is happened because all these members are that is student class members. So directly we can, and when we are trying to access age, so age is a that is private member of the class, so it will not allow us to call here or use the age directly. In order to display the age of the base class, here I need to call what function? Put age function. Simply put age. We need to call this public member function in order to get the age. Okay, and after that we are printing pin number, that is the member of the derived class, and L. Okay, and when this get age can be called, in order to display the age, we need to assign value for that particular variable age. But when this get age can be accessed, because here when the derivation is private, then all the members, that is public and protected members, become private. Okay, so private members can be accessed in public part. Okay, so for that here in get pin, I want to call get age function. Get age function. Okay, that's it. And display put age, everything is good, and this s dot get age cannot be accessed. Even this is also return an error only. Fine. Now compile save the file and compile the program, run it. Enter age. See, this is actually the public member of the base class and derived as private member in derived class. Pin 501. Age is 18 and pin number is 501. There is no access control on these members of the base class, though the derivation is private in derived class. Okay, so like that we can access the private and public members in private derivation in uh, derived class. Okay, now protected. Now protected. Here, the protected derivation means that the derived class can access the public and protected members of the base class. If the derivation is protected, then the public and protected members of the base class can be accessed. And public and protected members of the base class become protected members in the derived class. That is here, if you observe, this is a base class with these three access specifiers, and then now the derivation is protected derivation. So the public and protected members of base class become same. Public okay, in protected members, public protected members of the base class become protected members. Only the protected members become protected in derived class. Okay, when we are deriving a class in protected derivation, then all the public and protected members become protected in derived class. Public protected members of the base class become protected members in the derived class. The access control of the members is similar to that of private members, and protected members has more significance in inheritance as we discussed previously. So it is having its own significance because when we compare with public and protected, public and private, the protected can be used in order to overcome the drawbacks of these two access specifiers. So that's why it is having its own significance in inheritance. The protected members of a class have strict access these members and providing a mechanism for preventing accidental modification of the data members. So in order to prevent the accidental modification of the data members, here the protected members are having strict access. Strict access. Okay. Only the member functions of same class can access these members, and the protected members of a class are inaccessible outside the class. So when we are specifying this type of visibility that is protected, only the member functions of same class can access these members, and also the member functions of its immediate derived class can access these members. Of course, those are public and protected can access. Private cannot be accessed. And the protected members of a class are inaccessible outside the class like private members only. And information hiding is implemented using this protected members or protected visibility mode. We are also hiding the information like private, and the protected members can still be accessed. There is a way or there is a possibility of accessing private members of a class. So this is making the members of a class as protected members. So here simply we need to use the keyword protected. So as usual, all the data members and member functions. Okay, and here that is, we'll see when we are deriving this, we need to here write protected. Derivation is protected. That's why here when we are deriving the class student, we need to specify the keyword protected, or we need to provide that the class student is derived from the person in protected derivation. In protected derivation, for that, let me open Turbo C++ and try to modify the same code in for protected derivation. Okay, so here class person, private, public, and what I want to do is I want to use only protected. Why there is no need of any public member function? Protected. Okay. Why there is no, if that is private, at least we require one public member function in order to access that. But here what I want to do is I want to make all the members of this class as protected. That is int age and void get age. And even I don't require this code, because here the protected members can be accessed in its derived class. Okay, but they become protected, and the derivation is protected. Members are protected and the derivation is also protected. And pin number, get pin. Okay, and using this get pin, you can call this get age. Okay, because now this the protected member of base class becomes protected in derived class. So that should be called in public member function. So here only we need to write this get age and enter pin number, and here display, we need not to call any member function, simply cout see out the age is, okay, what is the variable age? Because here in derived class the protected member, here the age will become member of the derived class as protected only. So we can access that in its member directly, age. Okay, and as usual pin number is its own member, and in main student S, and S dot get pin, of course here S dot get pin calls get agent its own body. So we'll get enter agent enter pin, and after that in order to print simply s dot display. So here we will not get any error. Previously we used one public member function in order to get the value of age in private derivation. As this is protected derivation, we don't require any of such things. Compile, nearest, run the program, enter age, same values again and again I am giving. Pin C, the age is 18 and pin number is 504. Okay, let me show. If I want to access that age here in main, what happens? See out, see out, the age is, the age is, as that is the member of the derived class, so through the object only I can access, right, normally. So as dot age, let me compile it, say first save it, compile it, see for the errors, right. Person age is not accessible because here the age is protected member of the base class that can be accessed in its immediate derived class without any problem, but cannot be accessed out of that class or any part of the class. So here we are getting an error, right? So like that you need to do some experiments, that is making some members as private, public, protected, and even different derivations. You need to check and you need to cross-examine whether your program or the concept which you learn are is correct at the time of implementing. You need to take care of that. And here, if you observe, this is visibility, that is derivation type. Normally, there are three different derivations: private derivation, public derivation, and protected derivation. So, if base class is having, obviously it may have private, public, protected. In this case, we are assuming that base class is having all these three members, that is private, public, and protected, as well as derived also. If what happens then, if base class is having these three different types of members, okay, so this is not member, always I need to change everything. Okay, this is not member functions, like that we can change for everything. Okay, leave it here. This is the base class members, private members, public members, and protected members. If the derivation is private, obviously the private members cannot be accessed in derived class, so not inherited, and public members become private in derived class, and protected members of the base class becomes private members in the derived class, right? If the derivation is private, the public and protected members become private. Public and protected become private. And if the derivation is public, okay, then private members always not accessible or not inherited. And public and protected becomes public and protected only. That means here in public derivation, the public and protected members of the base class are not changing in its derived class. Okay, here public derivation, the public and protected members of the base class become public and protected in derived class. Okay, and if the derivation is protected, then private cannot be accessed and public become protected and protected become protected. The protected also become protected in derived class. So these three are the three different derivations. So when we are deriving a class in either of these three derivations, we need to concentrate on what happened or what is the accessibility of base classes in derived classes. Okay, so this is a entire table which shows the accessibility of base classes in a particular derivation in derived classes. Okay, now so till now we discussed the types of derivations, public, private, protected, and what is the syntax when we are deriving a particular deriving in a particular derivation, that is private or public or protected. Okay, only here we need to change the visibility mode. Of course, when we are came this particular visibility mode, when we have seen this visibility mode at the time of discussing the syntax of a derived class. Syntax for deriving a class. There the syntax is a keyword class followed by the new class name, scope is colon, and visibility mode, then base class name. So in that we discuss this visibility mode. And one thing you need to remember is, if you are not specified any visibility mode here at the time of creating a new class, then it takes private as default. Private as default. That means here it considered that as private derivation. Private derivation. Okay, so if you are not, even you can omit this visibility mode at the time of creating a new class or deriving a derived class. But if you are not, if you omit this particular visibility mode or access specifier, then the compiler takes private as its default access specifier or derivation. Okay, so also we have seen example programs for that, and this is the important one, and simply we will see what is meant by inheritance. Creating a new class or deriving a new class from an existing class is called inheritance. And here each and every derived and new classes are having its own different terms, and a derived class inherits the properties from the base class. The following are the main reason, that is what is the main reason for this particular concept in OOPS, that is inheritance in OOPS. Main concept is reusability. In order to reuse, by using inheritance, we can add features to an existing class without modifying it. It is based on the concept of sensibility. We are simply modifying, we are adding some code to the new class without modifying the existing class. So, based on this concept of sensibility, this inheritance concept was introduced, and we can derive a new class from existing one, and capability to express the inheritance relationship that ensures that is with the real world models and transitive nature of this inheritance. We use this concept in our programs, that is what is transitive nature, that is if class A is derived from class B, then all the other derived classes from A will get the features of class B. If a class A inherits properties of another class B, then all subclasses of A will automatically inherit the properties of B. That is called as transformation. Right? Thank you.